As mentioned previously in the previous video introduction, we say that we are doing multiply, which means that we have a lot of plies over here with different orientations, and we are keen to actually look for all of them, or if we were to stack them all together, or what type of stiffness matrix will we have, and what is the values, the Young model and everything. Okay, and therefore in this video we'll cover how do we so-called differentiate. Alright, like over here this is 90, or this is 0 degrees, or over here is this 45, or some other angles, things like that, which is the nomenclature. Then axial stiffness is some equations that we will talk about it, and then the longitudinal or the Young modulus and shear modulus of your laminate, multiply laminate. Okay, so therefore let's start. Okay, so for example, if you have a 8 ply, alright, as seen from this diagram, this is 1, 2, 3, 4, 5, 6, 7, 8. Total there's 8 ply. Alright, so in this sector there will be 0, 45, minus 45, 90, and so on and so forth. So it's talking about this thing. So when you're talking about your so-called laminate, alright, so this is actually looking, how do I say? So this over here is my 8 ply laminar, and if I were to arrange in this thing, alright, this is actually 0 degrees. Okay, so over here this is the x, this is the y, for example, this is the x, this is the y, so this is 0 degrees. And if you were to so-called tilt a little bit, so if you are tilting in this direction, because now it's this direction, so I'm tilting in this direction. Okay, so this is actually 45 degrees. Okay, then over here if you tilt in this direction, then it's negative 45 degrees. Okay, we have to imagine. Okay, so I repeat again, over here, this, if you were to look at this picture, this thing over here is the top one. Alright, this first one, like going like this. Alright, so it's actually 0 degrees. Okay, then over here it's slant in this angle 45 degrees. Okay, so this is why I draw 45 degrees over here. Alright, this picture is 3D, this picture is 2D, but hopefully it's pretty clear for either side of them. And over here this is negative 45 degrees. Alright, hopefully it's pretty clear now. Then if you were to go to this angle, then it's 90 degrees. Alright, it can be 90, it can be minus 90, but anyway it's just this straight line. It's perpendicular to the 0 degrees over here. Okay, hopefully this is pretty clear. And I think that's all, because it's only 45, 90, and that's all it is for the laminar. And therefore the rest should be the same, because they are actually 45 degrees only. Okay, hopefully you, so in other words, this is actually a 2D picture, this is a 3D picture, but I just want to show you both of them so that it's easier for you to understand clearly what the hell it is. Another thing to take note is that if you were to go clockwise, alright, if I were to take a look down in this angle, okay, this is my x, this is my y, for example. Okay, it's going in this direction, this is clockwise, correct? So it's actually a positive value. Okay, as you can see, clockwise is positive 45 degrees. Just like your math, okay, this is clockwise, it's positive. If it's going like this, then it's anti-clockwise, then it's negative values. Alright, it's just the same thing as any conventional angle question. But anyway, so this is for a long chunk of stuff. Alright, if you have t, or over here this is a value of, this is the alphabet t, and this tells you that for the full ply, for 8 of them, these are all of this. Okay, but if you take a look, this is actually a symmetry, 90, 90, minus 45, minus 45, 45, and 45, 0. Okay, and therefore if you know that it is a symmetry, you can simply rewrite this t as this type of form, which is a symmetry, so you can cut short your writings. Okay, however, if you have something like 80 degrees, then maybe this is 60 degrees, then this is 70, then you should use the t, this t thing, because there is no symmetry at all. Okay, if you have symmetry, then you can use this type. If you don't have, then you'll use the t one. Okay, so I have to keep on repeating. The t is for non-symmetry. The S is for symmetry, and the purpose of it is to cut short your writings, okay, so that it's easier and yeah, it's easier to write lah. Before we have somewhat clear away the nomenclature, or meaning the definitions of your so-called laminate, multiply, a lot of plies stacked together, okay. Then we go on to slightly examples of the nomenclature. Okay, as you can see, if we have a plus 45, 90, and minus 45, alright, as you can see, this is actually a symmetry also. This thing over here is the same as this one. So if you want to take a look at the symmetry, alright, imagine this is the mirror, alright, you're looking in this direction. This one should be the same as this one, alright, they should reflect, okay, because this is over here is plus 45, over here is plus 45, okay, so they are reflecting each other, okay. So don't be careless that if you this one over here is 45, 90, and minus 45, and then you put here plus 45, and then here minus 45, then then here 90, then here minus 45, is wrong, okay. So please remember, is the reflection, alright, it's the mirror reflection. This 45 and this plus 45 should be here at the end of the ply itself, okay. Hopefully this is pretty clear. Yeah, so another example is, I think 0 degrees is just straightforward, so yeah. So the 0, 1, 2, if you just remember, it's just the one direction and the two direction, that's all, alright. So it's 0 angle in the 1, 2 direction, so it tells us that it's going in this direction, okay. Finish already. Alright, so let's come back to the symmetry one again. Alright, so the first thing when you do this type of question is to draw in the middle. This is the mirror, alright. So whatever over here must be the same as this one when you reflect. Okay, whatever over here must be same as this one when you reflect. Okay, so this is definitely the symmetry. Okay, hopefully this is pretty clear. And another symmetry is 0, 90, 0, 90 again. Then yeah lor, this is 0, this is in between, alright. So this in between is the mirror also, alright. So this is 90, and then 0, and so forth, alright. So there are many ways they can set a question to actually trick you, so be very careful of that. So I'll recommend you do some examples your own, and then go and verify with the lecturer, see whether is it correct or wrong or whatever. Yeah. Nonetheless, there are some names you can take note, is that the standard plus minus 45 symmetry. So if it's a standard one, then it's just plus minus. If it's a hybrid, alright, then it's something else. If it's hybrid, it's something else, I don't know, but some of the names. Alright, so let's talk about the next one. It is our axial stiffness. Okay, so if you forget, or if you remember, V5.5 is the one that deals with axial stiffness for a one ply. Okay, so this is only a single ply so-called laminate. Okay, and the stiffness matrix, if you remember, is Q. Okay, your stiffness matrix, and then you have to inverse transform your Q together with your strain to get your stress, if you remember. So your Q is your stiffness matrix. Okay, however, alright, this is only a one ply system. What if we have a multiply? Alright, if we have many other plies, alright, some other plies, and you stack it together, what is the stiffness matrix then? Alright, it will be a slightly different stuff. The equation that we'll be using is actually this one. Okay, if you remember, there is a Qij bar. Alright, this is something like your not something like a, but it is, alright, something that we have learned before. Alright, it's over at your page 43 of your slide. Okay, lecture notes part 2. Okay, this is actually for your Q bar, for your Q bar, correct, for your Q bar. Okay, and your Q bar is taking your Q multiplied with certain multiple of itself transformed. But I think we have discussed before, this is quite familiar to you, the Q bar. Alright, Q bar is actually a transform stiffness matrix. Okay, I repeat again, this is actually a transform stiffness matrix. Go to V5.7 if you forgot, and in fact I already forget. And why don't we use Q, and why, sorry, it may arise that why don't we use Q? Why do we use Q bar? Why do we use a transform Q matrix? If you think about it, if you remember, this strain is in the one direction. Alright, this is in the x direction. So the x and the y is like this. While your 1 and 2, alright, is over here. This is the 2 direction, this is the 1 direction. Alright, so there will be a certain angle you need to shift. Okay, and trying to do that is a bit tough, right? So therefore you need to actually shift this strain first. Shift this strain in terms of x and y. And in order to do that, you need to transform your Q. Alright, and this is why you need a transformed stiffness matrix Qij. Okay, and therefore normally you need to use the Q bar instead of the one that I showed you. Okay, so please remember, don't use this thing. Alright, please use this one, the Q bar. The Q bar is the correct one. Okay, and let's come back here. So the Q bar, or is the one that we want, and the Ij is simply the Q12, Q11, Q22, etc., which is the matrix itself. Alright, so in other words, okay, if you remember, these are all your Q11, Q12, this is Q13, this is Q12, Q22, and all together they are actually Qij. Okay, and this is only for one ply. Alright, this is only for one ply. Alright, if you were to sum out all the plies, alright, so K is the number of ply. Alright, as it says, number of ply. So if you have 3 plies, for example, this is 3, this is one ply, this is the second ply, this is the third ply. Okay, and if you sum them up together, you'll get a total sum of all the stiffness matrix all together. Alright, but if you sum them out all together, alright, they are, in other words, these are actually 3 plies. Okay, so if you sum them out all the stiffness matrix over here, you're talking about summing out all the stiffness matrix against a certain direction. So when you sum out all of them, okay, you're talking about pulling in only one ply, alright, and then plus another pulling, alright, in another ply, plus another pulling from another ply. So over here they are strong in all this ply direction, alright, in a single ply only. Alright, I think you get what I mean. So this part over here is only talking about the total strength for each of the ply. Alright, when you sum them all together, but it's not the correct value. And this is why you need to multiply with a certain ratio. Alright, so if you don't understand what I've just said, then just forget it. Okay, but remember that once you sum out all of your different ply, so you need to have a stiffness matrix for your particular first ply, and another one for the second ply, and another one for the third ply. Sum them up first, alright, and then you find h divided by n, where your h is the total thickness of your laminate. Alright, total thickness means this total thickness, all of your laminate together, alright, divided by the number of plies, n. Okay, so in this case, you're talking about the whole average stiffness of your matrix. Okay, of your laminate. Okay, so it's a bit slightly hard to understand, but you just need to know that this is the ratio. Alright, and what they are calculating for this is actually to calculate only the average strength of only one ply. Alright, it's not calculating the average strength of the 3 plies. Alright, I don't know why, but this is the meaning behind this equation, if you think about it also. Yeah, so therefore need to remember that. So I need to repeat again. Alright, this value is talking about, alright, only this particular ply average, any of this ply. So there will be 3 plies over here. So this 3 ply, any of this one of the ply has the same as this Aij. They are all the same, the average. Alright, but by right they shouldn't have. Alright, by right is different. Individually they have this laminate strength of themselves. But if you average them up, this is the average one of it, and you need to use that. Okay, and please be careful. As such, we have cleared away the axial stiffness, and last but not least, the longitudinal and the shear modulus. Let's talk about it now. Once you get your Aij, okay, if you think about it, it's actually a matrix also. Okay, like this. Okay, is in terms of A11, A12, A13, because these are all in terms of a matrix also. So you sum them all the matrix and then multiply a certain ratio, you'll get this number. okay, this 9 numbers, okay, and if you were to take A11, A11, A22, alright, all these numbers, and you plug in over here, alright, this is A11, A22 minus A12 and all these things. So you just take the values and then you just multiply yourself. Ignore this one, okay, because there's no A33. Alright, A33 is for the shear modulus. Okay, but in any way of this, once you get your this one, straight away you can find your this one, longitudinal modulus and your shear modulus. And it's very important, it's one of the key first step to do things. So what you need to do is actually normally you find your QIJ first, and then get your QIJ bar, sum all of the laminate together, and then get a ratio, get an AIJ, and then you calculate your modulus, and then you can carry on to calculate all other stuff, alright, to determine the stresses and everything. Okay, it's a pretty long process. Therefore, we have somewhat understood the longitudinal and the shear modulus of the thing. Okay, and I think this is it. And the next video we'll talk about other stuff. Okay, yeah.